Good day, sir. My name is Shiva Sharman Anaki Panirselvam and my registration number is 01DKP22F2014. So today I'm going to explain about the transverse framing system in ship. In ship's construction, the framing system is the skeleton structure that supports the shell plating, which is the hull's outer skin, and provides strength to resist various stresses. One of the oldest and most widely used methods is the transverse framing system. So transverse framing system is a method of ship's construction which is the main strength members or frames that are arranged across the ship's breadth at closely spaced intervals, supporting the shell's plating and decks. So in this system, we have frames that are closely spaced, usually 0.6 to 1 meter apart, and the longitudinals, which are fewer in number but mainly acting as ties. So there are plenty of main components in the transverse framing system. So the first one would be transverse frames, which are the ribs of the ship running athwart ships. And next we have floors, the horizontal transverse plates placed at each frame across the bottom, strengthening the double bottom. Next we have deck beams, which are the transverse members supporting the decks. And next would be the web frames, which are larger, stronger frames at intervals to act rigidity. And the next one would be stringers, which are the longitudinals, limited in numbers but placed to stiffen between frames. So the characteristics are frames are the primary stiffeners. Spacing is small, well suited for ship with smaller length to breadth ratio. The advantages of the transverse framing system would be simple and easier to construct, and it provides good transverse strength which resists racking forces and rolling. It is effective for small and medium sized vessels such as tugboats, ferries, fishing boats and small tankers. And also the repair are easier because frames are accessible and replaceable. But the disadvantages of this system is heavier structure compared to longitudinal framing systems, not efficient for very long ships like modern tankers and bulk carriers because they need more longitudinal strength to resist hogging and sagging stresses. And there are more internal space occupied by frames, which reduces cargo volume slightly. The application of this system are mainly in small to medium ships such as fishing vessels, ferries, tugs, warships and passenger ships. For large ships like VLCCs and bulk carriers, longitudinal framing system is preferred or longitudinal strength. That's all from me. Thank you.
Myself, Abhiraj Analaki Sankaran, and my DKP number is 01TKP22F2004. And today I'm going to explain about longitudinal framing system in naval architecture. Okay, first, the definition of the system is a construction method in which longitudinal stiffeners are the primary strand members running continuously along the length of the ship. These are supported at the intervals by widely spaced transverse web frames and griders. There is four main components for the system. The first one is longitudinals. Small stiffeners running fore aft on the bottom side and deck of the ship, spaced closely about 0.6 to 1 meter apart. And secondly is the web frames. These are large, deep transverse frames spaced much farther apart, about 3 to 5 meter. They support and tie the longitudinals. After that is the deck griders or side griders, continuous longitudinal supporting the deck and the bottom structure. And finally is the floors, placed at the web frames position to support the double bottom. And I'm going to explain about the characteristics of this system. First are longitudinals are the primary stiffeners. They are resist longitudinal bending stresses. After that is the web frames are secondary, widely spaced supporting the longitudinals. And finally is the provide high longitudinal strength suitable for very large ships for the length to breadth ratio. These are the characteristics to the system. Then finally I'm going to explain about advantages and the disadvantages of the system. Okay, firstly, it provides excellent longitudinal strength, resists hogging and sagging and bending stresses in long ship. After that is a lighter structure compared to the transverse system, more efficient use of the sail. After that is the leave more clear cargo space because frames are fewer and farther apart. After that is the well suited for the large ship like tankers, bulk carrier and container ship. And the disadvantages of this system is construction is more complex than the transverse system and more difficult to repair and provide less transfer strength, so additional transfer bulkhead and the web frames are needed. And finally, not efficient for small ships. Construction cost and complexity don't justify it. That's all from me. Thank you.
My name is Sridharendu Singham. My matrix number is 01TKP22F 2015. Today I am going to explain about mixed or combined system. The combination of both transverse and longitudinal framing, often transverse framing in ends of ship fore and aft for the shape, and longitudinal framing is midship for bending resistant. The arrangement of the ship is midship longitudinal system and ends with transverse system. Web frames of intervals to tie both systems. Next we jump to circular double bottom structure. The description of the circular double bottom structure is the important for strength and safety, made of floors, transverse, longitudinal girdles and solid keel. Form of watertight tanks. The arrangement will be center glider along with keel, side girdles running longitudinally and transverse floor joining them. Thank you, sir.